Hey guys, welcome to another Theory of Computation tutorial. Today we'll be looking at some examples for DFA minimization. So let's get started. So let's say we are given this transition table. Let's construct the DFA for this transition table. All right. So let's use green color. All right. So let's say this is a starting state A. Okay. And when we get input 0, you go to state B. All right. And you get input 1, you are staying in state A itself. All right. Now in state B, if you get input 0, you are going to state D. State D. And since state D is our final state, double circle. Okay. And you get input 1, you are going to state C. And yeah. Now in state C, if you get input 0, you are going to go to state B. Okay. So you get input 0, you are going to go to state C, and you get input 1, you are going to go to state A. Okay, and in state D, you get input 0, you go to state A. Okay, and you get input 1, you go to state B. All right, so this is our DFA. Now we have to minimize this DFA, and we can see how many states we can minimize it. Okay, so now we have to check for the equivalence of the states. Okay, so what we'll do is first we'll check zero equivalence. Now what is zero equivalence? We have to check or divide the states in two groups, where one group is of all the states which are non-final states, and one group is of all the states that are final states. So zero equivalence is like this. We have got A, B and C, which are non-final states, and we have got D, which is a final state. So this is zero equivalence. Now one equivalence is states when depend on the input, we have to check is the output part of the same set of states or not. Okay, so let's say we have to compare A and B. So A and B. Now getting input 0 in state A, we go to state B, correct? And on input getting 0 from B, we go to state D. Now are B and D part of the same set over here? No, B is in this set, D is in this set. So that's why A and B are not one equivalent. Okay, so A and B are not one equivalent. All right, so what we'll do, we'll create a separate group over here for A and a separate group over here for B, and D is already present in the separate group. Okay, now we have to compare A and C. Okay, so let's say A and C. On getting input 0, A is going to B. Okay, and what about C? C is also going to B. Fine. Now what about input 1? So on getting input 1, A is going to state A. Okay, so you are comparing this. Okay, you are comparing A and C. Yeah, and on getting input 1, C is also going to state A. Okay, so that's why A and C are one equivalent. So A comma C. All right, now we have got three groups over here: A comma C, B and D. Fine. Now you have to check for two equivalence. Same procedure. Okay, two equivalence. All right, so now you compare A and C. Since we already know that A and C, on getting both input 0 and 1, they are going to states B and A. So that's why A and C are two equivalent. All right, and B there is nothing to compare, and neither there is anything to compare with D. So once you get two back-to-back equivalent states, you conclude and you stop over there only. So we have minimized this DFA. Now let's construct and combine these two states, that is A comma C, combine them into one single state and construct our new DFA. Okay, so how does the transition table will look like? So let's draw the transition table over here. Okay, so let's say we have got our three states over here. Okay, first let's write the input 0 and 1, and this is our first state, combined state AC. Okay, so on getting input 0, AC is going to state B, and on getting input 1, it is going to state A, but there is no state A. We have got a new state, it is known as AC, correct? Fine. What about the next one, that is B? So on getting input 0, it is going to state D, and on getting input 1, it is going to state C, but there is no state such as C, it is AC. Okay, now we have got our final state, that is state D. Final state, yeah. On getting input 0, it is going to state A, but we have created a combined state called as AC, so it is going to state AC. And on getting input 1, it is going to state B. All right, so this is our starting state AC, then state B, and final state is D. Now let's draw this DFA and see how it looks like. Okay, so this is our starting state AC. Okay, on getting input 0, it is going to state B. On getting input 1, it is staying in state AC. What about state B? On getting input 0, it is going to state D. And on getting input 1, it is going to state AC. All right. And what about state D? It is a final state. On getting input 0, it is going to state AC. And on getting input 1, it is going to state B. So this is how we have minimized the DFA from 4 states to 3 states. Now let's try to pass a string and see if it works out or not. Okay, so let's say we pass a string like what string should we pass? 0 0 and 0 0 1 0. Okay, let's try this string 0 0 1 0. So you're in state A, you get input 0, you go to state B. You get another input 0, you go to state D. You get input 1, you go to state B. Then you get 0, you come to state D. Is it in the final state? Yes. So this string is accepted by this DFA. What about this DFA? So let's say you're in state AC, you get input 0, you go to state B. Again you get input 0, you go to state D. Then you get input 1, you go to state B. And again you get input 0, you come to state D. Is it a final state? Yes. So this string is also accepted by this minimized DFA. So this is how we minimize our DFA. So that's it for today, guys. If you have any queries, feel free to ask me in the comment section below. Thank you very much.